All right, then. Today we are going to bring in molarity. Let's take a look. Everybody get to that page. I want to make sure that I keep you guys on task with the other group. So molarity, I want to put this here, make sure I keep up with it. Molarity is simply a concentration. What is concentration? That's what I do when I'm working hard on my homework. Different. Concentration. What does that mean to you? Hudson, do you drink orange juice?
Yes, I like
Yeah,
orange.
what's it say on the bottle? When you're sitting there eating your eggs and bacon or whatever you eat for breakfast and you got your orange juice, on the bottle it says made from
Concentrate.
concentrate, right? What does that mean? We never thought about it.
There's less water.
Water. That'll work, Margot. And what were you saying? Yeah. Condensed form is what's being said in class. So basically what they do is, have you ever had a bad orange? And you're like, this orange sucks, kind of? They've never had a bad orange. Like you bite into it and you're just like, oh, something's off about this taste. How do you eat oranges? You swallow them whole though? Bite into a slice of orange. How's that? You're thinking I'm eating it like an apple, like a savage. That is not true. So what they do is they basically take the oranges and they take out the liquid. They dehydrate them, and that's how they make that concentrate. They do that, like Tropicana has a very distinct flavor. They've had the same flavor for quite some time. They do that to preserve that flavor because, I mean, have you ever been to a burger place and you're like, what did they do? Like, this burger doesn't taste anything like the normal burger I get here. Or your mom makes meatloaf and she's like, I'm gonna try some new recipe that I read online. And you're like, what did you do? Right? We don't want those surprises. Especially like Tropicana or something like that. They don't want all of a sudden their flavor to be different. They don't want to throw you off because then you're like, I don't like Tropicana anymore. I'm going to get a different brand, right? So they want to give you the same thing each time. So what they do is they have a bunch of concentrate oranges that they can add to the mix. Just in case it's a bad year, they can use some of those older oranges that they've taken the water out of to preserve them and throw them into the mix to give that constant flavor. So basically concentration is how much of a thing you have over, let's say the total, maybe the total amount, or maybe it's to compared to another thing. So these are the basics of this, right? How much of a thing compared to another thing or divided by the total amount that you have. The concentration for us, this is for a chemical solution. When do you guys normally take health class? Over the summer. Who was the teacher over the summer? Was it all just like online stuff? So one of the lessons in health class, they teach you about drugs and alcohol safety, right? Yeah. So does anybody know how they measure concentration of alcohol in a beverage? Good. Good that you guys don't know this. Right? If you sit there and we're like, I'd be like, whoa, they may know too much about alcohol. So in a beer.
How much alcohol over like how much total liquid?
Yeah, that's exactly it. It's by percent volume. So a beer is about 4 to 6% by volume. Now that's average. Like a can of Budweiser, I think it's 4.5% alcohol by volume. That means if you had 100 milliliters of the substance, 4 of those milliliters are ethanol. Right? So that's a concentration. A wine is 10 to 12% alcohol by volume. So if you had 100 milliliters of wine, 10 would be ethanol. Now that's double, right? So how many ounces are in a pint? You guys are so used to the metric system, you don't know this? A pint is 16 ounces, right? So you might have 16 ounces of a pint of beer. For wine, you would have 8-ounce glass of wine, right? So if we take a look at this, that's why they say 1 beer per hour or 1 glass of wine per hour, because that's the amount of alcohol that the average person would be able to break down in 1 hour. 1 beer or 1 glass of wine. And what is this equal to when we come to what they call spirits? Or you might have heard it called as hard liquor or something like that. Well, hard liquor, they base that off of a system known as proof. Now, this is from the early days whenever you had bootleggers and stuff like that, and they wanted proof that this was hard liquor. Well, the thing to give proof was you lit it on fire. If it lit on fire, that's 100 proof. Well, what's the percent alcohol of 100 proof? Well, that would be divided by 2 to give you 50% alcohol by volume. That's much bigger than 4% or 10%. So a shot of liqueur, in reality, most of these liqueurs are 40% because they're 80 proof. So I'm going to go ahead and put 40% here, because that's the majority of them. You might have something, for example, Bacardi 151. I don't know if you guys have heard of these. Probably not. But that's 150 proof, so it'd be 75%. But 40% for the spirits. This is why your teacher in those classes would have told you that for a shot of vodka or something like that, that's 1.5 ounces. Because of the percent alcohol by volume, 1.5 ounces of a spirit per hour, 1 glass of wine per hour versus 1 pint of beer per hour. These percentages right here dictate the serving size that you should be able to have. Well, not you, because you guys are 21, but based on the serving size, that's where that information comes from. That's why they say, okay, 1 of these is equal to 1 of these is equal to 1 of these, based on the serving size, because then your body is getting about the same amount of alcohol, which your body can actually break down over that hour. Questions there? That give us at least a decent idea. What are some concentrations in your life? That gives it a concentration for the dye you use? No? Anybody? Concentration. So let me ask you this. Have you ever done your own laundry? Yes. How did you know how much detergent to use? How about you at home? We got freestylers here like, yeah, that should get them clean enough, I guess. You type now they got the pods, right? Now I don't have to do any thinking. Olivia said that
There's a line on the cup.
there's a line on the cup, right? The actual lid itself tells you how to measure the right concentration for that soap. If you're not freestyling. That's how they tell you how concentrated to make that if you're using a full load of laundry, right? What are some other things? Now, I mean, they're heck of convenient, right? Like, boom, the Tide Pods. They got pods for the dishes. Those are the actual measurements that you need. They've already taken that thought out of it. Why are they more expensive though?
Because it's already done for you.
It's already done for you. But here's the other thing. Think about this. If they didn't do that, when they shipped that, what would they have to, if they had the actual bottle of the liquid again? Which one is the cheapest of all of them? Is anybody old school and still have the scoop and the powder? If your parent cares about money, you might be there. Because the scoop and the powder is the cheapest one. Why is that the cheapest?
Because it's the easiest to manufacture.
Easiest to manufacture? Maybe. There's another cost you're not thinking about.
No water.
No water. Why is that a big deal?
Water costs money.
Yeah, but water's not that expensive. But where does the water cost the money?
Weight and size.
Weight. And how does that affect it? Shipping, right? You already have water at home. If they make the powder, they know that you're going to have the water at home. It's the shipping. If they don't have to ship the extra water, which takes up weight and size, they can sell it to you cheaper. So the powdered form is the cheapest. The liquid form, it's more expensive to ship and everything like that. The pods, again, it's the processing and manufacturing costs. Like you said, they've taken out the work, but it's also putting that liquid in the little film and all of the extra processing and manufacturing. But one of the things about those is the concentration of those is very high. That's why they're so compact. And that's why a few years back, I mean, I don't know if this even a thing anymore, but the Tide Pod eating thing. Yeah, there used to be like a thing like where people were like trying to do an internet challenge where you eat Tide Pods, but that is so concentrated that it could do, and when we'll get to acid-base chemistry, maybe we'll watch the film on it, but that could do some serious damage. Very concentrated. All right. Let's bring you closer to the idea of what the most common concentration measurement for chemists is. So we want to be able to calculate the molarity of a solution. We're going to calculate the amount of solute needed to prepare a solution given molarity. We will describe the preparation of a solution of a given molarity by dilution of more concentrated solution. This is where we're going to get today, 1 and 2. So we should already have the definitions for solution. We know they're made up of a solute and a solvent. The solvent is the larger quantity, or what you might say, what does the dissolving? The solute is a smaller quantity, or what is dissolved. So if we take a look, the term molarity actually is 2 units. You take the number of moles, welcome back mole, and you divide it by the liters of solution. So let's say I have 2 moles of sodium chloride, and I put that in 500 milliliters. How do I find the molarity of that? Do my units match? No worries. What do I need to do? I need to change from milliliters to liters. So I need to change this from milliliters to liters. Anybody got any ideas? Been a while.
Be 0.50, it'd be 0.5 liters.
Mr. Joseph said. For those of us that can't do all that stuff in our head, does anybody know how many milliliters are in a liter? 1,000, student of the month right there. There are 1,000 milliliters in 1 liter. Why did I put milliliters up top? to cancel out the unit, right? Okay. 2 divided by 500 times 1,000. What's that? Oh. The answer is 4. So today at lunch, they gave all the students that are in here a cotton ball and paper clip and bubble wrap to help them reduce stress. I did 2 divided by 500 times 1,000. Remember, it's on top, you multiply. If it's on bottom, you divide. Oh, we get 4 moles per liter. Another way to say that is 4 molar. You'll hear me say 4 molar solution of HCl. That means that every liter of that solution, there are 4 moles in that. What does that mean? That means 4 moles of particles, or 4 times 6.02 times 10 to the 23rd particles floating per liter of that solution. So we're bringing back a lot of concepts. So hopefully you have the basics for this. All this is a game of stoichiometry. So if we take a look here, calculate the molarity of a solution made by adding 141.7 grams of nitric acid to enough water to make 750 milliliters of solution. So I want molarity, which is moles per liter. Something last semester I taught you hopefully was that if I want 2 units in the end, that means I need to start with 2 units in the beginning. So which of these units can get me moles? Because I want to put that one on top. $141.7 grams can get me moles. And which one can get me liters? Milliliters. So I put the grams on top and I need to change that to moles, and I put the milliliters on bottom and they change that to liters. If you're smart like Gavin, you could sit there and be like, actually, it's 0.750 liters, and you just saved yourself a step, right? All I did was move the decimal 3 places to the left, and that makes it milliliters to liters, right? I'm sorry, it makes it liters to milliliters. So now all I've got to do is change from grams to moles. Well, this is hydrogen, nitric acid, so HNO3. So with this, I have 1.01 for hydrogen, 14.01 for nitrogen, and 3 times 16, which is 48, for the, help me out, for the oxygen. 1.01 plus 14.01 plus 48. 63.02 grams is 1 mole. Why did I put the 63.02 grams on bottom? To cancel out. So now all I do is take 141.7 divided by 0.750 times 1 divided by 63.02. 2.998 moles per liter, or 2.998 molar. Anything done too fast there? Anybody not see where we got some digits? The question is a significant digit question. 1, 2, 3, 4 significant digits. I rounded this to. If we take a look, 141.7 has 4, and 0.7500 has 4. So both of these have 4 significant digits. So my final answer should also have 4 significant digits. Comfortable with that? What are you breaking now? The what? They also give you paper to tear into little bits. That's funny. That's your oh, that's amazing. whenever we were a kid, we had a home ec class, and I don't know if this is ever offered anymore. But in 8th grade, we were at a home ec class, and basically it taught you how to cook and sew and stuff like that. And one day we were doing this lesson on how to get like a first job. And one of the first jobs that she talked about was becoming a babysitter. And she was like, to be a babysitter, you need to be creative and come up with things. And I'm sitting there thinking, like, somebody in administration is like, let's give these kids trash so that they will be okay. Like, give them a paper clip, stuff that we can land around. Anyway, it reminded me of a friend that I was actually good friends with him then, Stephen Few. But she goes, what kind of toys like might you have that you could bring with you to babysit a younger child? Like, and some kids were like, well, I'm in art class right now, so I have clay. And some kids were like Play-Doh, and some was like Legos. And Stephen Fuchs got lard in a bag. And I don't know if you guys know what lard is, but it's like Crisco. But if you put this in a bag, like you could easily, like I'm sitting here watching you guys like play, like these things are entertaining, high school students. Lard in a bag would be fun for a child, I'm sure. Like, you know what lard is? Like Crisco, right? Like fat, yeah, like baking grease in a bag, like you could sit there and form it. But basically, that's what that one thing is, isn't it? Do I have that too? Yeah. It's lard in the bag. All right, moving on. Why are we off here? Why are we off?
Their like molar mass was different than ours.
We got ours directly from the periodic table. They must not have. They must have estimated nitrogen to be 14.00. The other thing is, and if you've been with me for a while, whenever I teach you guys, I try to teach you the way I do it because I think it's easier. And I told you guys I don't like to think very hard. But the way they've done it is they've actually solved for moles first, and then they solved for liters, and then they did the division. That means that these two right here were rounded already. Well, this one was rounded already. When you do it this way, there is no rounding done until the very end. So I'm assuming it's because they did a rounding here, which might have changed it. You're more than welcome to do it this way. All my tests and stuff will give you that variable, plus or minus something error. But this is the better of the two. All at once is better. But if you're having difficulties and you know how to solve for moles and you can solve for liters, then by all means do it in separate ways. I'll tell you though, if you're looking for molarity, you need to start with two things and put them on top of each other. Let's try this problem. Go ahead and try that on your own. I'm gonna get a drink or something like that. Video is that all the destruction that you've done? Yeah. The cotton ball was supposed to smell good, but it smelled like your grandma's house. They actually give you My grandmother smoked until like she was like 67, so we did not enjoy as kids hugging her just because she smelled like smoke. In her house, like if we stayed the night there, as soon as we got home, everything we had like blankets and clothes went straight to the laundry. What have you been doing? I do. What do you want? Texas speed is pretty good. Yeah. It's a little better than Tabasco, I think. It's no Mad Max, but what is? All right. Hopefully that was enough. Did anybody get the molar mass of rubidium chloride? 120.2. I'm going to go ahead and use that just because I want to. 120.92 grams is 1 mole. That's all we did for the last one. This time we're going to go ahead. We need to change this 250 milliliters unless you're like Gavin and you just went ahead and did it. That's good on you. But I'm going to put 1,000 milliliters is 1 liter. I want to stress that whatever there is there cancels. And we want to make sure that we do this until we get the units that we want, which is moles per liter. 2.42 divided by 250 divided by 120.92 times 1,000. How many of you just used their 121 and stopped right here? You did that, you're wrong. Why is this wrong? Why is that only worth 8 out of 10 points? No. We actually need 2 more significant digits. You need 3 significant digits total here. Yesterday, whenever somebody was doing the lab, I heard somebody say, I thought the 0 before the decimal is not significant. They were right. I didn't hear how that conversation ended, but these 2 zeros right here are not significant. This answer needs to have, oh, dang it, you were right. 250 only has 1. So I am corrected. I'm sorry, 250 only has 2. So I am corrected. It should be 0.80. There we go. Since 250 only has 2 significant digits, it's based off of that, and that is our final answer. Again, we could rewrite this as this right here. I am hoping somebody was genius enough to sit there and think about the kids' period after lunch and how crazy the popping of the bubble wrap would make their teachers. Because that is funny if somebody was like, you know, and I bet there are some teachers out there that are just like, why would they give those kids bubble wrap right before they come into, you know, theory of knowledge? Who is the theory of knowledge teacher? Mr. Hodson still? All right, so let's take a look at this. Oh, look at this. How many grams of sodium hydroxide should she use? If you were thinking that the chemists are only males, shame on you, right? A chemist wishes to prepare 0.500 liters of an 8 molar aqueous solution of sodium hydroxide. How many grams should she use? This right here is the most common type of problem you will do on it. It's not often that you're sitting there in the laboratory and you're like, oh, I got so many grams of this and I got so much of this solvent laying around here. I'm going to mix them together and I wonder what molarity I'm going to get. That's not very accurate. What normally would happen is you would sit there and you'd say, hey, I need 8 molar solution. I need how much do I need? I need 400 milliliters. So I need to make a half a liter of an 8 molar solution. Well, how do I do that? And I'll tell you, those biology teachers, they work hard on the biology, but over the years, many, many times have I been asked, hey, how do I make this solution? And it's this problem right here that teaches you how to make this. If you can do this, you could probably do most of the work of somebody who lives the life of a lab tech, because you're making solutions, you're cleaning glassware, stuff like that. You're getting paid maybe $45,000 to $60,000 a year for it, right? I mean, that's the thing. You got to be able to make the solution though. Well, the thing is we're looking for how many grams that we use. Now that's the key. This right here tells us what we need to solve for. And that's the problem most people have, is they're like, I don't even know where to start. Well, how many grams of this we need? Because what is a solution? We have a solute and we have solvent, right? For molarity, you need to know the moles of solute, and you need not the solvent, but you need to know the volume of the solvent plus the solute. That's the weird thing about this too, is we can't just say, I'm going to take 0.5 liters of that and add something to it. I need to say I add enough water to make 0.50 liters. So how many units here? One. So that means I need to start with one. If that's confusing you, just say it, grams. That's one thing. Grams is one thing. That's one measurement. I can measure that. What is molarity? Moles per liter. That's 2 units. Moles over liters. That means I need to start with 2 things over here. This says grams. That's one thing. I need to start with one thing. Is liters one thing, or is molar one thing? Well, I just said molar is moles per liter, so that's 2. So I'm going to start with liters. Right? So that's my volume that I want in the end. Well, every 1 liter has to have how many moles? Yeah, fill that back up. Every 1 liter has how many moles? I'm having trouble making that connection. What's from
Is it
the,
8?
yeah, 8, right? It says 8, and maybe this is the problem. You need to read this as 8 moles per liter, or 8 molar means 8 moles per liter. So every 1 liter has 8 moles. Actually, it's 8.0 moles, but am I done? No, I need to go from moles to what? Grams. The molar mass, every 1 mole is how many grams? Well, they give it to us, 40.0. Unless you want to get it from the periodic table. 0.5 times 8 times 40? 160 grams, is that correct? How many significant digits? How many significant digits? 2. So my final answer has 2 as well. I think you should be stressed out. Less than 2 seconds later. Go ahead and take a minute and a half to do this one down here, please. Exercise 2. What were they like? The wire and stuff you were talking about? Yeah, be more gentle with it. That thing that I gave you. That's $300. Yeah. Because it's an educational tool, and they think they can put any price on it because it's cool and taxpayer money is paid for. And there's nothing better than it. Oh, I over exaggerated. It's only $215. Yep. Because we went all out and got the 4x4 lattice, didn't we? And that 4 of them by 4. Yep. And that $215. That's insane, isn't it? That's funny. You got 2 3x3s. Did you make a 4x4? Did you make a 9x9? Right? It's harder than a problem, but I bet you could make a 4x, like you could make a 4x4 by buying 2 of the 3x3s, right? And it'd still be cheaper. I think. Oh, maybe not. If we made it 2x3. That's the power. I get Hudson's probably sitting there going, those guys are dumb. 3x3, obviously. But what is it? You could probably figure out like it's a multiplication thing. Just that one extra one, but it's how many more are you already changed it. All right, let's take a look here. A chemist wishes to prepare 275 milliliters of a 2 molar aqueous solution of sodium hydroxide. Oh, they're sitting there reading that garbage. Boom. Good thing you guys are here. Keeping me straight. A chemist wishes to prepare 275 milliliters of a 2 molar aqueous solution of sodium hydroxide. How many grams should they use? We want grams in the end. So that's 1 unit, 275 milliliters. If we do it the Gavin way, we can go ahead and take out 1 step real quick. Right? In every 1 liter has to have how many moles? 2 moles. And every 1 mole has how many grams? 40 grams. So if you used to love this stuff, I think it might be only Emma. Or do you like it too? Yeah. If you liked this stuff before, you're going to love this unit because this is a lot of what we do. So 0.275 times 2 times 40.
It's 22.
22 grams. Is that answer worth all the credit? No, it should be what? 22.0. If you weren't in here last semester, this may be the first time we're coming across this, but I do grade on significant digits. So if it's a problem that's worth 10 points, the most you can get if you don't have the significant digits correct is 8 points. If you don't write the units, that's 2 points as well. If I didn't do it this way, oh my God. The question is, how would I have done this if I didn't do it this way? So let's go ahead and I'm going to try to do this. This is very difficult for me, but let's take a look. The first thing I would need to do is find the number of moles. So I have the molarity, which is equal to moles per liter. So then if I take the liters and I multiply it by the number of the molarity, that would give me moles. So the first thing I would do is 275 milliliters divided by 1,000 milliliters times 2.00 moles per liter. So that right there would get me moles. 275 divided by 1,000 times 2. So 0.550 moles. Now I would need to do a second step where I change this into grams. So every 1 mole of this is 40.0 grams. 0.55 times 40. So if you were separating everything out into multiple problems, you would have to go through all these steps. And you can see that my brain stopped twice just trying to think of how to do that. Whenever I'm doing it this way, I didn't think at all, right? My brain was like, okay, I got to get the grams. I have liters. Every 1 liter is this. Every 1 mole is this. Boom. So you can see, I mean, I'm not saying that this is beyond you by any means, but I'm using a lot more processing power than I feel like I need to. Questions there? So this diluting and stock solution is what we're going to do tomorrow. You will be quizzed over up to tomorrow on Wednesday. So keep that in mind. Watching me play basketball does not make you a better basketball player. Watching me do chemistry does not make you a better chemistry student. You need to go and do some problems on your own. So please try 1, 2, 3, and 4 tonight. And you do have some time right now. I hate to give you guys homework on what is tonight, personal project night, but if at least do 2 of them so that you feel comfortable, and don't just do 1 and 2, like do 1 and then 4 or something like that. All right. And if you're really on a struggle bus for this, there are so many problems. Currently, you guys can do up to problem 7 in reality. So if you're like, whatever, personal project was awesome, I'm done because I was smart and did the history thing, and you have all the time in the world, by all means, go for it. Yeah, did you do the history thing? No. Have a great day, guys. If you have questions, by all means, stick around. I want to hear more about Mia's personal project, though. See you, Hudson. What did you do instead? You probably have already told me, but